Hello, Stardust Explorers, and welcome back to today's episode of Stardust Discovery. And we are continuing with discussions on waves and light. So, on today's episode, we'll be looking at refraction of light. This question will be taken from the Physics WASSCE question of June 2021. And here is the question I'll read. State scientific principle underlying the operation of fiber optics. B. Part of this question, explain each of the following terms as used in fiber optics. I, core. II, cladding. So this question is about fiber optics. And fiber optics is one of the applications of waves and light, a very useful application in our world today. And then to understand the question and explain it, it's important that we go back to the properties of waves and in particular refraction. Under refraction of light, there are so many applications of that. Refraction happens in different medium. It happens in water, between air and water, between glass and air, between lenses. So there are so many medium that could be used to explain refraction. And there are certain circumstances whereby refraction could be converted to what is called total internal reflection. And that's is one of the things we'll be looking at today, one of those extreme situations where refraction becomes a total internal reflection. So, getting to it, the first question, state the scientific principle underlying the operation of fiber optics. So, I would say that it's important you know what fiber optics does, what is required, how does it even work, because that's where you can get the answer to this question. So, fiber optics, in simple way, it involves transmission of light through thin strands of highly transparent material. The point here is that light is transmitted through materials of high refractive index compared to their surrounding. Most times it's glass or plastic. And the principle here is total internal reflection. Now, I think it's also important that you understand what total internal reflection is. I have given a summary of that on the screen, but I would encourage you to read your textbook, check the links on the description box on the details of this topic. Really, they are very simple to understand, the links I provided, and hopefully you understand more about the topic if that's useful for you. So total internal reflection occurs when light travels from a medium with a higher refractive index, such as a glass, to a medium with a lower refractive index like air. It can be refracted or bent away from the normal line. So if you remember how you represent reflection and refraction of rays, your ray diagram, you normally would have this line drawn. You have the normal line that is at 90 degrees to the surface, and then your reflection can happen on either ways, as well as your refraction. So depending on light, that's really what reflection means. So for this scenario, when light travels from a medium with high refractive index to a medium with a low refractive index, for example from glass to air, light is refracted. It can be bent away. Now, the bending could continue until the angle of incidence, that is the angle that the reflected angle, or rather the incident angle, is making with the normal, that angle is what you call the angle of incidence normally. So the angle of incidence, if you continue to increase it and it goes beyond a certain critical angle, so there is a critical angle that if the angle of incidence exceeds that critical angle, all the light will be reflected back into the glass, that is into the medium with a higher refractive index. And when this happens, we say that total internal reflection has occurred. Okay, I will ask you to go back to follow step by step what I just explained, in case you did not get it. But that's really what it is. And this principle is used in different applications. One of them is fiber optics. The next question is now trying to ask you about the different parts of the fiber optics and what their function is all about. Now, it's important to understand fiber optics, the different parts, especially in relation to the total internal reflection we just explained. So we have the core. In the fiber optic system, the core is usually the central region, and that's where light actually passes through. Most times it's made of glass or any material that has a high refractive index, because you want to make sure that there is that contrast. So a high refractive index material should be made for the use for the core, and a material with low refractive index should be used for the outside, which will be getting to the cladding. So the core is responsible for guiding the light signals through the length of the fiber, and this is only possible because of total internal reflection. Now, your ability to get this question into your full marks, 1 mark for the core and 1 mark for the cladding. So I've already given it away in the first one. The cladding is the outside, so it's the coating. The coating that you give to the fiber system in the outside, it has to be made with a material that has a smaller refractive index compared to the core. That way you prevent light from being refracted between the fibers. Okay, I hope this was helpful. If you want me to maybe make additional video on this, let me know, and then feel free to ask your questions on the comment section. Again, subscribe, like, and comment, and share this video. And as usual, I will leave you with some words of encouragement that sometimes the bravest thing you can do is not giving up when you feel like you are on the verge of breaking down. And I hope you have a wonderful time going through this video, and I will see you in our next one. Bye.